Hello, welcome back to this fourth model, and my name is Mr. Awesome Emmanuel. So, in this particular lesson, we'll be considering areas and angles of plane shapes. Areas and angles of plane shapes. So, let's get started. But before we continue, let's just lay some basic theoretical foundations before we actually build. Now, from our basic knowledge of plane shape, we know that plane shape, they are two-dimensional shape made from line segments enclosing a region. So, and we have examples of these plane shapes. Examples are triangles, quadrilaterals, circles, and many other polygons. So these are just plane shapes. In other words, plane shapes are just two-dimensional objects. The plane shapes are two-dimensional objects. So the next thing we want to actually consider is just to see the content of this lesson. Now, to see the content of this lesson, the first one we'll be considering is perimeters of plane shapes. We're going to be looking at the perimeters of plane shapes. And the second thing we want to consider the areas of plane shapes. And lastly, we want to consider some angles in polygon. So let's actually get started with the first one. Now, perimeters of plane shapes. Now, from our basic knowledge of perimeter is just the summation of the outside boundaries around a shape. So the perimeter of a shape is a measure of the distance around the boundary or the edge of the shape. So with the usual lettering, the perimeter of some basic shape, for instance, a rectangle, is 2 into the bracket length plus breadth. Now the perimeter of this basic shape, square, is 4 length, that is 4L. The perimeter of a circle is 2 pi r, that is when we're talking in terms of the radius, and just pi d when we're talking in terms of the diameter. Now the perimeter of a circle is also called the circumference of the circle. Now there are other circles again that they may not be basic, but the concept of perimeter is just the summation of the outside boundaries around any plane figure is called the summation of all this outside boundary is called the perimeter. So now let's start with some basic example. Now the first one I have here, I have a list of examples from 1 to 10. Now we're going to see how far we can go with these questions. They are pretty simple, but let's get started. Now the first one says, if the perimeter of a rectangle is 20 meters and the breadth is y meter, express the length of the rectangle in terms of y. This was actually pulled up from Cowbellpedia 2018 question. Now, but before we actually solve the problem, let's establish some relationship as regard rectangle. Now, I'll come to rectangle. The perimeter of a rectangle is 2 into the bracket length plus breadth. That is the formula. But when we're looking for the length of a rectangle, to get the length of a rectangle, it is the perimeter divided by 2 minus the breadth. That's how to get the length of a rectangle. Now, to also get the breadth of a rectangle, it is perimeter divided by 2 minus length. These formulas are very important. Now, having these formulas at the tip of our finger will enable us to solve this question easily. So the question actually asks us to get the length of the rectangle, but take note, it has to be in terms of y. Y is the breadth, and the breadth was not actually given in the question. So now to get the length of the rectangle, it is p over 2 minus breadth. The perimeter is 20. Now 20 divided by 2 is 10. Then also we'll have 10 minus y, all in meters. So the length of the rectangle in terms of y is 10 minus y meters. As simple as that. Now the next questions under perimeter, I trust we understand the first example we just solved. Now the next question under perimeter is how to actually calculate the perimeter of a rectangle is 20 centimeter. What is its breadth if its length is 8 centimeter? The same thing from what we just established in the previous slide. We said the breadth of a rectangle is perimeter divided by 2 minus its length. So the perimeter in this case is 20. So 20 divided by 2 is 10. So 10 minus 8 is 2. So the breadth is 2 centimeters. Okay. Now the question number 3 says, what is the perimeter of a regular nonagon of side 4.70 centimeter each? Now, a nonagon is a polygon that has 9 sides. Now, regular means all the 9 sides are equal in length. And when they are equal in length, it also means their interior angles are also equal. We'll discuss polygon in the third part of this lesson. Now, what we're going to do is, now to get the perimeter of this nonagon, like we said earlier on, the perimeter of any shape is the summation of the outside boundaries of the shape. This nonagon is a 9-sided polygon, so it has 9 sides. So since it's a regular shape, it means each side is equal to 4.70. So to get the total length of the shape is 9 times 4.70. So perimeter of the regular polygon is equal to 9L, 9 because it's a nonagon. Now let's actually refresh our memory. Starting from polygon, the first one on the list is actually triangle. A triangle has 3 sides. The next one is quadrilateral. A quadrilateral has 4 sides. Quadrilateral to then pentagon, pentagon, hexagon. Hexagon has 6 sides. Pentagon is 5. Hexagon is 6. Heptagon is 7 sides. Octagon is 8 sides. Nonagon is 9 sides, and decagon is 10 sides. So that's just the basic we should always remember. And there are higher values of polygon, but at least for your level, you should be able to recognize the first 8 polygon, that is from the triangle to decagon. So to get the value of the perimeter is just 9 times 4.70, and the answer will give us 42.3 centimeter. Now that is just that for that. Now question number 4. The perimeter of a square is 16 meters. What is the length of each side? Now before we actually continue, we have to know the perimeter of a square. The perimeter of a square is 4L, where L is the length of the side. So to get the length of the side now is perimeter divided by 4, and perimeter divided by 4 is to get the length of the side. So the perimeter is actually 16, so 16 divided by 4 is 4, so the length of its side is 4 meters. Now the next question is question number 6, which says the length of a rectangle is 4 times as long as its width. Now if the perimeter is 180 centimeter, find the length of the rectangle. So since we're actually looking for the length of the rectangle, let's establish something. The breadth we don't know, so we can actually call the breadth B. Now the length, from the statement we are told that the length is 4 times as its breadth, which is actually the width in this case. So the length will be 4B. So from our formula, which is 2 into bracket length plus breadth, our length is 4B, then our breadth is B. 4B plus B will give 5B. Now we're told that the perimeter of this rectangle was actually 180, so it means 2 into bracket 5B can be equated to 180. This is actually give us 10B. So to get our B now is 180 divided by 10, and 180 divided by 10 is 18. So we're getting the breadth to be 18, but the question is actually asking for the length. Now since the length is 4 times the breadth, so the length will be 4 times 18, and 4 times 18 will give us 72 centimeter. I trust you understand how I actually solved this problem. Okay, now let's actually continue. The next question is question number, oh, I thought I solved this up to 10, but okay. Now let's give it up to you. Solve okay, I remember I didn't actually solve all. I solved some while I picked some for you as your classwork. Okay, let's start with your classwork. I'm gonna give you time for each questions. So for the first one, let me actually bring up my timer. Okay, my timer is even there. So for the timer is there, I thought I didn't actually add a timer. Okay, let me just give you some time to read through the question. I understand you can't actually solve everything here under 20 seconds, but let's see how it works. Now take your time and solve the first one. Let me give you some time to solve. You have 5 questions, and that 5 questions, let me just give you 5 minutes. So you can actually start now. I'm giving you 5 minutes to solve the questions. Your time starts now. Okay, you should be in number 7 by now. After actually work with time, should be in number 8 by now. Increase your speed. Okay, I think you should be solving question number 9. Okay, number 10. Don't worry if you're unable to meet with my time demand. You can just practice more to gain speed, because the competition is actually speed and accuracy. Okay, I think we're good to go. So I'm giving you extra 20 seconds. Extra 20 seconds. So let's watch that. Okay, I think we're good to go now. Okay, let's start with the first one. Find the perimeter of a square of length 3x meters. So the perimeter is square. The formula for perimeter of a square is 4L. So since each side is 3x, so the 4 sides add up together will give us 4 times 3x, which is 12x meters. That's how we got the first one. The second one, find the length of each side of a square with a perimeter of 64. To get the length is perimeter divided by 4. So 64 divided by 4 will give us 16. So that is how we got 16 meters. Now, number 8. What is the perimeter of a circle whose diameter is 14? Now, in this case, since the perimeter is in terms of the diameter, so the formula we're going to use is pi d, which is 22 over 7 times the diameter is 14. So 7 here 1, 7 in 14 is 2. 2 times 14 and 2 times 22 should give us 44. That's how we got 44 centimeter. Then number 9, what is the perimeter of a square whose length is 20? So 4L, 4 times 20 will give us 80 meters. And the last one is given that C is 2 pi r. Find C when pi is 20 over 7 and r is 21. It's going to be simple. 22 over 7 times 2 times 21. 7 here 1, 7 here 3. So 2 times 22 times 3. Let's see our answer to be 132 centimeter. I trust we should be able to get the 5 questions, then we are actually good to go. That is all for perimeters. Now let's actually come to the next part of the lesson, which is area. Now, what is the area? Area is just the region bounded by a shape. That is, the amount of space a shape covered is what we call the area. Now, the area of a plane shape is the amount of space it occupies. So area discusses the amount of space it occupies, or the region a shape occupies. This is measured by finding the number of square units needed to cover the surface. So let's actually go into details. Now, but before we go into details, let's actually revise some basic areas of some plane shapes. Now, when we discuss plane shapes, take note, maybe you can actually jot something down. When we talk of triangles, now we have basically I think maybe 6 forms of triangle. The scaling, the 3 basic type of triangle, the equilateral, scaling, and the isosceles. Are the 3 basic. But when it comes in terms of angular classification, we have right angle triangle, we have obtuse angle triangle, and we have the acute angle triangle. For all forms of triangle, the area of the triangles remains half base times height. So, but when we come to quadrilaterals, I think we have basically 6 types of quadrilaterals. Now, the 6 types of quadrilaterals are: number 1, we have the square, we have the rectangle, we have the rhombus, we have the kite, we have the trapezium, and we have the parallelogram. And let's just run through the areas of these 6 quadrilaterals I just mentioned. For a square, the area of a square is L squared, that is length times length. For a rectangle, the area of a rectangle is length times breadth. Then for a trapezium, the area of a trapezium is half into the bracket the sum of the 2 parallel sides, then multiplied by its height. That's the area of a trapezium. Then the area of a parallelogram is the base times its perpendicular height. That's the area of a parallelogram. Now the area of a kite and a rhombus, they are actually the same. Now the area of a kite or a rhombus is half multiplied by the first diagonal times the second diagonal. In other words, is half multiplied by diagonal 1, diagonal 2. At least I dropped some of the formulas in some part of the lesson, so as we continue, we're going to notice that. So let's just see some sample questions on that area and let's solve them. Now the first one says the area of a square is 625. Find the length of its side. Now area of a square is L squared. So to get the length of its side is square root of the area, and square root of 625 is 25, so to be in meters. So the length of the side is 25. Now some questions can be encompassing in the sense that in this question you are asked to find, you are given the area, you are asked to find the length of the side. You can be given the area, you will be asked to find the perimeter. And in this kind of case, if you want to get the perimeter, after getting the side, what you're going to need to do is just multiply it by 4. So you now apply the formula for perimeter of a square, which is 4L. So 4 times 5, 4 times 25 rather, should give us 100 meters. So take note of such kind of questions too. Now, number 2, the length of a rectangle is 12 centimeters. That is the length of the rectangle. Now, if its breadth is half the length, the breadth is half the length, what is the area? So what we're going to do is simple. If the length is 12, and we're told the breadth is half of the length, which is L over 2, so L over 2 is 6, so it means the breadth is 6. So what's the area? Area of a rectangle is length times breadth, so it will be 12 times 6, which is 72 centimeters square. So the area is 72 centimeters square. Now let's look at this question number 3. It's very important we note this down. Now, 2 similar figures have corresponding side in the ratio 2 to 5. Now, if the area of the smaller figure is 40 centimeters square, find the area of the second figure. Now, there's a relationship when it comes to questions of this kind, and the relationship is this: ratio of the side, the square of it is equivalent to the ratio of the areas. Now, you can be asked, you will actually be surprised, how do we actually get this? Now, let's use a square, for instance. Just pay attention, get your piece of paper and follow what I want to say. Now, if we get to write down 2 squares, the first square, let the length be 5 centimeters. Just do that. Then the second square, let the side be 10 centimeters. Have you done that? Okay, follow me. Now, the area of the first square is 5 times 5, which is 25. So write 25 as the area of the first square. The area of the second square is 100, write 100 as the area of the second square. Now find the ratio of the side of this square, starting from the smallest to the biggest. So the ratio of the side for the small one is 5/10. So if we reduce it, we'll have 1/2. Now come to the area. Find the ratio of the area. The area of the small one is 25. Then the ratio and the area of the big one is 100. Reduce it down, we'll have 1/4. Now you will observe that for them to be equal, the relation between the side and the area, if we square the ratio of the side, the 1/2 all squared, if we square it, it will be equivalent to 1/4, which is actually the ratio of the areas. So that was how we got this formula or this relationship, that ratio of sides is equals to ratio of side all squared is equals to ratio of areas. So in this case now, the ratio of the sides are 2/5, so 2/5 all squared. Now take note, this is small over big. The small area is actually 40, so it will be 40/x. So now if I square this is 2 squared is 4, this is actually 4/25, just taking note of that. So I'm looking for x, so x will be divided by 4 here. So 5 will times 40 over 5 will times, sorry, not 5 here is 25 now. 25 will times 40 divided by 4. 4 here 1, 4 in 40 is 10, 10 times 25 is 50. So the area of the second figure is 250 centimeters squared. I trust we'll get that down so we can actually note it. Now that brings us to question number 4. Now in question number 4, we're told that if the area of a given square is 576 centimeters squared, find the perimeter of the square. This is actually simple too. So area of a square is L squared. So the length of the square is to the square root of area, which is square root of 576, and square root of 576 will be 24 centimeters. So hence perimeter now will be 4L, 4 times 24, which is 96 centimeters. So that is for number 4. Then we'll come to number 5. Calculate the area of a triangle whose height is 12 and base is 8 centimeters. To do that, the area of a triangle is half base times height. So the half into the bracket 12 times 8. 2 in 12 is 6, so 6 times 8 is 48. So we get our answer to be 48 centimeters. Okay, now let's look at this number 6 question. Now this question says, what happened to the area of a square when what happened to the area of a square when each of its sides is half? When each of its sides is half. Now let's actually explain this. Get the piece of paper while we explain. Now let's assume the square before is the side is 10 centimeters. So the area of this square will be 10 times 10, which is actually 100. Now we're told that when each of its side is half, when each of the side is half, or actually half now is 5, 5, 5, 5 all around. And the area of this square now, when the side is half, is 5 times 5, which is 25. Now you will observe something, that when the side is half, the area of the small one is 1/4 of the area of the original square. I trust you understand what I'm saying. The area of the small one is 1/4 of the area of the original square. So that is actually what the question is trying to get us. So what happened to the area of this square now when its side is halved? Now look at my statement. When the side of a square is halved, its new area becomes 1/4 of the area of the original length. That is the area of the original length. I trust you understand that. So whenever the area of a square, whenever the side of a square is halved, the area will be reduced by 1/4 of the area will be reduced to 1/4 rather of the area of this original shape. So that is just what the answer is there. Now come to question number 7. Now, what is the area of a square whose diagonal is 12 centimeters? Now let's just actually, okay, I've actually put a formula here for us to just see something, but I think I will explain. Now we know area of a square is L squared, but from Pythagoras theorem, from Pythagoras theorem, this square equals to 2l square. Now I want to prove that to you. Now get your pen also. Now draw a rectangle and draw a square. Now from a square, each length is L. So the area of a square is L square. We all know this. Now draw a diagonal of this square and call that diagonal D. Now you know each angle of a square is 90 degrees. So the diagonal, this what we have there is like a right angle triangle. And from Pythagoras, this square will be equals to L square plus L square. That is what Pythagoras tells us, that the sum of the other two sides, that is the Pythagoras states that the hypotenuse square is equal to the sum of the other two sides. So that is this square, from what I'm just explaining, this square equals to L square plus L square, which will give us 2L square. So it means this square equals to 2L square. But L square, from the first equation we have here, L square is A. So we have a relationship now that diagonal square is equals to 2 of area. So this is a relationship that the square of diagonal is twice the area. So in this case, if we want to get the area when diagonal is given, is diagonal square divided by 2. The diagonal in this case is 12. 12 square is 144, and 144 divided by 2 is 72. So the area of the square when the diagonal is 12 is 72. You can actually note something of this kind down. Now let me just drop some notes before I actually continue. I explained them verbally before we actually came to the slide, but let's see them on the screen. Now the area of a trapezium, I've said it before, is half into the bracket sum of parallel sides times the vertical height, while the area of a rhombus and the area of a kite are actually the same, the half diagonal 1 times diagonal 2. Time will fail me to prove it for you, but in this composition I doubt if you'll be asked to prove, just understand the formula. Now the next one is actually a parallelogram. Area of parallelogram is the base times its perpendicular height. Take note, not a slant height, it is the perpendicular height. Okay, having taken note of these formulas, think I have the next thing I have for you should be a text of mastery. Let me see how good you are when it comes to areas of plane shape. So we'll have 4 questions, and these 4 questions, let me check how many minutes I should give you for the 4 questions. Okay, I'll give you 2 minutes each. So you will stop 8 minutes after this my time. So your time starts now. You can start 2 minutes each. I want you to get everything. I want you to get 4/4. So the time starts now. Start. You have spent a minute. Ensure you score 4/4. I've spent 2 minutes. 3 minutes. I give 8 minutes. Okay, maybe I'll reduce it to 6 minutes. I want you to be fast at what you do. That is why. Checking my time. Okay, you have 2 minutes to go. Okay. Ensure you score 4/4. Ensure you score 4/4. You have 1 minute and some seconds. Take note, I've reduced the time to 6 minutes. 1 minute and some seconds to go. Few more seconds to go. Okay. Get ready to stop. And from my own time, 22 seconds remaining. 22 seconds remaining. Okay, time's up. Okay, now the first one. Find the area of a parallelogram whose base is 25 centimeter and height is 10 centimeter. This is simple. Base times height, base times perpendicular height. So 25 times 10, 25 centimeters square. The second one, from what I just explained shortly, two similar figures have corresponding sides of 3/5. So to solve that, it will be 3/5 all squared equals to 144 over x. So to get x now is 25 multiplied by 144 all divided by 9, and the answer we'll get is 400. Now the third one, a rhombus. Okay, yeah, I have to explain this. So just get your notes while I explain. A rhombus has side 13 centimeter. Draw a rhombus. I trust you understand how a rhombus look like. It's like a tilted square. Now the side is 13 centimeter. The side of a rhombus are actually equal, so all the sides are 13 centimeter. Now from the rhombus you have drawn, the diagonal from the left to the right is actually the shorter one, while the diagonal from the top to the bottom is the longer one. So the shorter diagonal is 10. So draw a line from the left to the right of the diagonal as 10 centimeter. When you do that, now want to get the diagonal of the other diagonal. So if we draw the other diagonal, the diagonal actually bisect each other for a rhombus. So bisect means it divides that 10 into two equal parts. So we have 5 centimeter and 5 centimeter. So to get the length of one half of the second diagonal, we use Pythagoras theorem. And using Pythagoras theorem, we'll get that place to be 12. How do we get 12? 13 square minus 5 square will give us that point, which is 169 minus 25, and 169 minus 25 will give us 144, and square root of 144 is 12. So we have 12. So the other point too will be 12. So the longer diagonal now is 12 plus 12 is 24. So from the formula of area of a rhombus is half times diagonal 1, which is 10, diagonal 2, which is 24, and that will give us, okay, 2 in 24, 2 in 24 you give us 12, 12 times 10, 120, 120, sorry, not 720, 120. So the value here is actually 120. So I trust you understand how we actually solve this now. If you want me to explain again, I will do that. What we did was we got the half side of the second diagonal to be 12 using Pythagoras. So the long part of the diagonal now will now becomes 12 plus 12, which is 24. So the length, the area of the shape now becomes half times diagonal 1, 10, times diagonal 2, 24, and that will give us 120. Now the last one, calculate the area of the trapezium whose sum of parallel side is 13 and the distance between the parallel side is 10. So they have already added the parallel sides to be 13. So the answer here is actually 65. How? It is half times 10 times 13. 2 here 1, 2 in 10 is 5. 5 times 13 is 65. So if you get 4/4, thumbs up for you. I respect your mastery with this topic. So let's actually continue. Now this actually brings us to the last part of this lesson, and in the last part of this lesson we'll be considering polygon. Now the first kind of polygon is actually a triangle. Now a polygon is a plane figure with at least 3 straight sides and angles. That's why I would say triangle is the first one. The smallest polygon is a triangle which has 3 sides. The number of sides of a polygon determines its name. So that is why you observe when we have a triangle, it started from the word tri or trio as it's actually often called. So a triangle has 3 sides, a quadrilateral has 4 sides, a pentagon has 5 sides, and so on. I've actually explained this in the previous part of this my lesson. Now let's see some basic properties of polygon, or of some basic angles before we actually dive into polygon. Now the first theorem we just want to recap is angle on a straight line. Sum of angle on a straight line is 180. We know this already, just like a recap. Now second part to recall is so angles at the point, sum of the 360. This angle at the point is 360 degrees. Now the next thing is vertical opposite angles are equal. How do you actually know vertical opposite angles? I always tell my students they are x angle. What it means is the value up and the value down, they are equal. The value to the right and that to the left is equal. So vertical opposite angles are x angle. Now corresponding angles are also equal. How do you know corresponding angle? Corresponding angles are actually f angles. Corresponding angles are f angles. The value angle you have here and the angle you have here, they are equal. The angle you have here and the angle you have here, they are equal. Corresponding angles are f angles. The next one is all called the alternate angles. Now, how do we actually know the alternate angles? The alternate angles are z angles. Simple. The alternate angles are z angles. In other words, if you have a z angle, what you have, the alternate angles there, they are z angles. And the last part, sum of angles, sum of 2 interior angles, sum up to 180 degree. Sum of interior angle is 180 degree. Let's ignore the stroke, please. Then let's just see them in pictorial form. Now look at this. I'm still under this. I'm just trying to lay foundation under this topic. They are not really under polygon, just to lay foundation anyway, because we're going to be using them today. Now sum of angle on a straight line is 180 degree. What it means is this is a straight line. The angle formed at this point O, that is angle A and angle B, the sum up to 180 degree. It can be more than 2 angles. You can have 3 angles and many other angles there. So here the same thing. The angle x plus angle y plus angle z is 180. So this is angle on a straight line. Now the next one is sum of angle at a point. When we have a point, the sum of the angles formed at a point is actually 360. For this particular example, angle A plus angle B plus angle C is 360 degrees. The sum of the 360 degrees. Now the same thing applies here too. Now all the sum of this angle WXYZ or VWXYZ, all sum of the 360, sum of angle at the point is 360. Now this is the vertically opposite angles I talked about. Vertical opposite angles are when two straight lines intersect, they form a vertically opposite angles, and the angle formed opposite each other is actually equal. So in other words, if here is angle 40 degrees, this other up part is also 40 degrees. If here is angle 50 degrees, this other up part is also 50 degrees. So this is what we call the vertically opposite angles. Now this one, the corresponding angle, like I said, is the F angle. Now the F angle, all I have here, this place corresponds to this place, so we'll call them corresponding angles, and they are equal. If here is 80 degrees, this point will be 80 degrees. The same thing, look at my cursor place. This point and this point also are also corresponding. Follow my cursor place. This point and this point, they are also corresponding. This point and this point, they are also corresponding. So we'll call them corresponding angles. The other part is the alternate angles. Like I said, they are Z angles. Z in the form, it may not actually be a perfect Z, but they just look like a Z. Now, how do we know alternate angles? Well, we have two parallel lines and a transversal. That reminds me, when you have a parallel line, a straight line that crosses the parallel line is what we call a transversal line. And the transversal line passes through these parallel lines. And we have multiple kinds of angles that are actually formed from there. And in this particular example, alternate angles are the angles from here. The angle here and the angle from here are alternate angle. So they are actually Z angle, and alternate angles are equal. Now the last part is what we call the co-interior angle. Now the co-interior angle, we have parallel line and a transversal. The angle in here, this point and this point, they are called co-interior angle or interior opposite angle. So when you add them up, they sum up to 180 degree. Co-interior angles sum up to 180 degree. These are just basics before we actually go into this topic we're actually considering. Now let's just also see some basic review of polygon. The reason why I actually revise is because some questions and the later part of this lesson will require us the knowledge of these basic properties. Now let's revise actually the interior angles of polygon. Now how do we get the interior angles of any polygon? The formula has actually been given to us to be n minus 2 times 180 degree, or 2n minus 4 times 90 degree, whichever you want to use. Now in this case, n just means the number of sides of the polygon. So for instance, if we want to get the value of the sum of angles of a triangle, n will be 3. So 3 minus 2 is 1. So 1 and 180 is 180. That is actually how we got the value of sum of the interior angles of a triangle to be 180. The same thing applies to a quadrilateral. For a quadrilateral, n will be 4. And 4 minus 2 is 2. 2 times 180 is 360, and so on. I think a pentagon is 540 because 5 minus 2 is 3, and 3 times 180 will give us 540, and so on. Now this is just the formula to get the interior angle of any polygon, either regular or irregular. This is the formula we use. Now, but when it comes to exterior angle, the exterior angle of any polygon is actually 360 degree. The exterior angle of any polygon is actually 360 degree. Take note of that. Now, when we say irregular polygon is a polygon that have all its sides equal and the value of its interior angle, each interior angle are equal. A good example of a regular polygon is an equilateral triangle. For an equilateral triangle, you will observe that the sides are all equal. The 3 sides are equal, depending on any value actually, but the angle itself, each angle is 60 degree. So an equilateral triangle is a good example of a regular polygon. Another good example of a regular polygon is a square when it comes to quadrilateral. Now a square, all its sides are equal and each interior angle of a square is 90 degree. So a square is also an example of a regular polygon. So take note of a regular polygon. A regular polygon is a polygon that has its sides, all its sides equal to each other, and the angles also are also equal. The angles are equal, the sides are equal. That is a regular polygon. Now lastly, the size of each interior angle of a regular end polygon is 360 divided by the number of sides. This formula is actually very important. Take note, we're going to use it today. Now, if you want to get each exterior angle rather of a polygon, 360 divided by the number of sides will give us the exterior angle of that polygon. But take note, there's another formula actually I didn't add it here, but let me explain. You can actually note it down. There's a formula that says interior angle plus exterior angle of a polygon is actually 180 degree. My marker is not here. I would have shown us what I actually mean, but I will show us in the course of this lesson, one of the shape there. But take note, let me take it again. Interior angle plus exterior angle will give 180 degree. The reason is because they lie on a straight line. But as we continue, we get to understand this. Lastly, take note of this. Exterior angle is 360 by the number of sides. That's how to get the exterior angle. So it also means if we want to get the number of sides of a polygon, 360 divided by the exterior angle will give us the number of sides of that polygon. Very important. Now let's actually come to problems. I think I was only able to solve one problem here, then the rest I gave you to solve. Let's say that. So we want to solve this problem. Now, at times you don't need to be told which kind of polygon is this. The angle itself will tell you. We have 1, 2, 3, 4 here. We have 4 angles here. So this tells us that this is a quadrilateral. So the question says find the value of 3x in this place. So the first one we have to do, we have to find the value of x first. So to get the value of x, we'll add up everything. So x plus 3x plus 2x plus 3x equals to 360. The reason is because sum of angle of a quadrilateral is 360. Now, if we add everything up, x plus 3x plus 2x plus 3x, everything will give us 9x. So it means 9x equals to 360. So x will be 360 by 9, which is equals to 40. So since x is 40, the question says we should find 3x. So 3x will be 3 times 40, which is 120. Now, some other question can also just ask you to find the difference between the largest angle and the smallest angle. The largest angle in this case now is 3x. The smallest angle is x. So 3x minus x will give us 120 minus 40, which will actually be 80. So that is just that. Now, let's see what I have next. Okay, let's consider our test of mastery. I've been explaining for some time now. Now it's up to you to prove how good you are when it comes to polygon. Now you can pause the video, take a glass of water or a bottle of cold drink, then before we start. When you are done doing that, I've actually exhausted mine, but at least it's 3 minutes more. Just freshen up a bit, then let's continue. If you are done, can unpause the video. Let's start. Okay, now we'll have the first question. It's up to you. Solve the first question. It's up to you. Your time starts now. I will actually give you 1 minute per question. 1 minute per question. Your time starts now. One minute per question. Get ready to start. Okay, time up. The first one, what will be your answer? If you get 80 degrees, then you're correct. It's similar to the last question we just solved. The value of x is 40 degrees. So to get to x is 2 times 40, which is 80 degrees. Number 2, I'm giving you 30 seconds. You should know the answer. 30 seconds. And your time starts now. 30 seconds. From my explanation, you should just know what the answer should be. In short, 15 seconds. And your times. That is time up. The answer is what? Vertically opposite angles are equal. So if K is 70, B is also 70 degrees. Now, number 3, I'm giving you 1 minute. No, 30 seconds. Should be fast. 30 seconds. Start. Angle at a point. You should know the value. 30 seconds. Six seconds to go. And your time up. The answer is 30 degrees. How do we get 30 degrees? Angle at the point is 360. So y plus 2y plus 3y plus 6y. The answer will give us 12y. Now that 12y, 360 by 12 will give us 30 degrees. That is for question number 3. The next question is question number 4. If x and y are corresponding angles, what is the value of z? I'm giving you 10 seconds. Corresponding angles are equal. The answer is 112. Number 5. If d and v are alternate angles, find the value of d when v is 80 degrees. The answer will be alternate angles are also equal. 80 degrees. This is 80. Now, number 6. If each interior angle of a regular polygon measures 120 degrees, how many sides has this polygon? This question, I think, let me give you 60 seconds. So the time starts now. Process it, think it very well. Then when you're done, I wanted to say tell me your answer. I thought it was a Zoom class. Okay, 60 seconds. How I wish this was actually a Zoom lesson, so that we can actually hear ourselves. I'm giving you 60 seconds to solve this. Four seconds to go. And time's up. Now, how do we solve this problem? I emphasized a particular formula the last time. Now, this question is saying, if each interior angle of a regular polygon measures 180, how many sides has the polygon? Now, the relationship we need to use now is exterior angle is equals to 360 divided by n. Now, is the n we are looking for. So it means the n now is 360. N is just the number of sides. It means 360 divided by exterior. But in this question, we are given interior. So we have to get exterior. Interior plus exterior sum up to 180. So if interior is 120, exterior will be 60. So to get the number of sides now is 360 divided by 60. And 360 divided by 60 will give us 6 sides. So this polygon is actually a hexagon. It's a hexagon that the sum of each angle, or sum of each interior angle is 120 degrees. Okay. Now that is for number 6. Number 7, find okay, x is given x, 3x, 2x are all angles in a triangle. Find the value of x. So let me give you 30 seconds to solve this problem, and your time actually starts now. 30 seconds. You can see my time. I'm using my stop clock, my stopwatch. Time up. Now, to get the answer, add up all these values of x plus 3x plus this to give us 6x equals to 180. To get x now, 180 divided by 6 is 30. Now, number 8, each exterior angle of a polygon is 20. How many sides does it have? You should know the answer. I will give you 30 seconds because I've explained something of this nature before. And just by enjoying our class. Okay, I was tempted to ask you for a response, not knowing it's not a Zoom class. Okay. Oh, time's up. The answer is what? Now, we want to get the number of sides. Number of sides here will be 360 divided by exterior. So 360 divided by 20 will give us 18 sides. Number 9. Calculate the fourth angle of the quadrilateral whose other three angles are 100, 150, and 80. How do we solve this problem? Add all these three angles together, subtract it from 360, and we'll get 30 degrees. The last one, if A and 2B are angles on a straight line, find the value of A when B is 40. I think let me give you 30 minutes here to solve. Start. 30 minutes to solve. Time's up. So B is 40. So since B is 40, 2 times 40 will give us 80. So take it from 180, we'll have 100 because 180 is the sum of angles in a straight line. So the value of A is 100. Trust we had a very good time solving this problem. So let's see what we'll have next. A quick quiz. I'm sure you are not tired because I am not tired. Okay, let's see what we have here. I'm giving you 20 seconds. I think it's too much. It's too much. 20 seconds is too much. This my timing was super. I should have used 5 seconds timing or 10 seconds timing. Anyway, I'll stop you when it gets to 10 seconds. Which of the following angles is complementary to 36 degrees? Your time starts now. I'll stop you when it's at 10 seconds. Okay. And the correct answer, complementary angles. Complementary angles are angles that sum up to 90 degrees. Supplementary sum up to 180. Complementary sum up to 90. And what will I add to 36 that will sum it up to 90? The answer is 54 degrees. So that should be option A. So number 2. Yeah, I love this quick sharing. Now find the value of x in the figure below. This one I'm giving you 20 seconds. So 20 seconds. Time up. Okay. Now let's solve it together. There's a theorem I said they are co-interior. Co-interior angles sum up to 180. What it means is this angle plus this angle sum up to 180. So if we add them up and equate to 180, we have 35 plus 130, which is 165, plus x equals to 180. So to get x is 180 minus 165, and the answer will give us 15 degrees. So the value of x here is 15 degrees. The reason is because 15 degrees added to 130 plus this, everything will add up to 180. So that is for question number 2. Question 3. Now this question is actually sweet too. Now read it before your time starts. If two vertically opposite angles, listen. If two vertically opposite angles are complementary, use your brain. If two vertically opposite angles are complementary, and the adjacent to one of the complementary angles is 3x, find the value of x. And your time starts now. If you actually use your brain, you will get the answer. Correct, time's up. Okay, now let's see it. If two we know vertically opposite angles are equal. And now we are now told that these two vertical opposite angles are complementary. So it means they are 45, 45. So the other angle that is adjacent to one of the 45 is 3x. And you know, adjacent angles are angles that actually form, in this case, it's a straight line. So it means 45 degrees plus 3x equals to 180. So to get x now, it will be to get 3x now, it will be 3x equals to 180 minus 45. 180 minus 45 will give us 135. So 135 divided by 3. 135 divided by 3 will give us, I think the answer, 45 degrees. 45 degrees is the answer. So what did you get as your answer? Yeah, I agree again. I thought it's Zoom. It's not Zoom. The answer is 45 degrees. That is option B. I trust you enjoy this particular question because I did as well. Okay, let's go to question number 4. Now, the angles of a triangle are in the ratio 4, 5, 9. Find the smallest angle of a triangle. Let me give you 10 seconds. Okay? Start. I'm giving you 10 seconds. Okay, let me add 5 more seconds. Okay, in short, just use the remaining 5 seconds. Time's up. How do we solve this problem? Add sum up the ratios together. 4 plus 5 plus 9. This will give us 18. So 18. So the smallest angle should be the smallest ratio. So 4 over 18 times 180. Because sum of angle in triangle is 180. So 180 by 18 is 10. 10 times 4 is 40. So the answer is 40 degrees. So yeah, I love this. Find angle x in the diagram below. Find angle x, and your time starts now. You have 20 seconds to do that. Time's up. Now let's see it. Now vertical opposite angles are equal. So if here is 60, here too is 60, it means Z is 60. Now we have a triangle. Sum of angle in a triangle is 180. So 40 plus 60 is 100. 100 take it away from 180 is 80. So the answer is option C, 80 degrees. And I think that should be the last question. Wow. I think this class was actually nice. I enjoyed it. I don't know about you. Practice questions. You have 12 questions for you to practice. Thank you very much. And this is where we draw the curtain for this particular model. See you in the next class and have a nice time. Bye.